Welcome. So today we're going to work with a couple of things. We're going to talk about, given a point on the terminal side of an angle, what's the sine, cosine, tangent, secant, cotangent, cosecant, cotangent? What are the different values? Another thing we're going to work with is the sine of any particular trig function, depending upon which quadrant its terminal side is in. What happens when you have one point like this, but that ends on an axis? And then law of sines. That's the final thing we'll talk about today. So, let's get started with this. In this, we're talking about a particular point, the point 8, -15. Let me just move this up a little bit more so I can get to it. There we go. So the point 815 is 8 -15, excuse me, is somewhere 8 -15, somewhere around there. So if I were to draw a ray to that, here's that ray coming out to that point. Well, I have other sides to this. The positive side goes out to 8, roughly there, I think. And then the negative side, or the -15 part, comes down from there to make, well, that doesn't quite look like a right triangle. I think I need this part over a little bit more to make a right angle, and that means this comes out a little more. Okay, now there's my right triangle. I've got my nice little box for my right triangle here. Let me just move that into position. There's my right angle. Now, the other part of it is theta is this angle here. We always want theta with these to be the angle that's next to the origin. So there's my theta. We already know that this is -15 and that this is +8 because the x is 8, the y is -15. So when I want to find the remaining side, Pythagorean Theorem, 8 squared plus 15 squared equals, now this is going to be your radius, r squared I'm going to call it. So when I do this calculation, we know 8 squared is 64, 15 squared is 225, so r squared is, let's see, 15 squared, yes, it's 225, plus 64 is 289. Then we'll square root both sides. That's a funny equal sign. Yeah, it's better. And r ends up, I think that's 17. Yep, 17. So let's put that in purple, 17. It really should be blue, shouldn't it? Matching the line. Okay. So there's our three sides of our right triangle. Now when I want to fill these in, sine we know is opposite over hypotenuse, so -15 over 17. Let's see, cosine is adjacent over hypotenuse, 8 over 17. Tangent is opposite over adjacent, -15, that's not a very good 5, over 8. And then we also remember that tangent and cotangent are reciprocals, so 8 over negative 15. We know that cosine and secant are reciprocals. Cosine and secant are reciprocals, so 17 over 8. And that sine and cosecant are reciprocal. Sine's negative 15 over 17, so therefore cosecant is 17 over negative 15. And there are your 6 trig functions, all done for any particular point that we could find. Well, that's wonderful. So, what about some generalizations to make it so we don't have to draw out this object? Well, it turns out that if I draw out a right triangle in the first quadrant, where my point, terminal point, is somewhere there, this is my theta, and my values here, this is r, it's the distance out. It's always positive, by the way, and we'll show why in a minute. This is my x, and this is my y. We could do the same thing over here if it were in quadrant 3. And we would find y, x, r. We could do the same thing down here in quadrant 3. That was quadrant 2. I think I said 3 by mistake. This is quadrant 2. My y would be here, and my r would be here. And I could do the same in quadrant 4, right? So when we think about this, in general, theta, let me keep drawing my theta in. Theta is here for this one. Theta is here for this one. Notice in all of these, including if I drew this one out here, you've got your x, your y, and your r. In all of these, theta is here. Y happens to be the opposite. Y is opposite, so it's y, sine is going to be y over the hypotenuse radius r, and I'll show you why it's radius soon. Cosine is x, x is the adjacent in all of these, over r, and tangent is opposite, y over x, the adjacent. Let me just adjust that color. There we go. All right. So if we continue with this same thought process, we can just take the reciprocal here, x over y. For cotangent, the secant is reciprocal of the cosine, so r over x, and the cosecant is going to be reciprocal. What color did I use there? Come on. Black. So r over y. And if you have those listed, that makes it much easier if we have a point like negative 3, 4. Wherever I see an x, I'm going to put negative 3. Wherever I see a y, I'm going to put 4. And wherever I see an r, well, negative 3 squared plus 4 squared equals r squared. 9 plus 16 is r squared. We know 9 and 16 are 25. And when I square root both sides, r is 5. Now you see why I'm going to get a positive value for r. no matter what, because I'm squaring both of these values, and that automatically gives me a positive value. So x is negative 3. So anywhere I see an x here, I'm going to put negative 3. Negative 3. Negative 3. Negative 3. And there's one more down here. Negative 3. Wherever I see the y, I'm going to put a 4, and r is 5. Oh, I forgot my... There we go. Y is 4. R is 5. Y is 4. R is 5. Y is 4. And there you have all of the trig functions all done out. When you're given a point like this, much faster to plug in, once you know those, to plug them in, given the point and the radius. All right, let's take a look here. When you think about each of these sine trig functions, in the first quadrant, x, y, and r are all positive. X, y, and r. They're all positive. So you're taking sine is y over r, so that's positive. Cosine is positive, and tangent is positive. Well, if all of them are positive, no problem. In the second quadrant, x is negative, but y and r are positive. X is negative. So if x is negative, what includes x? Well, let's go back here. Cosine includes x, tangent includes x, and sine does not. So, wrong side. All right, so sine is positive, but cosine and tangent are negative. All right, we'll talk about what's on the right in a minute. In the third quadrant, x and y are both negative, and r is always positive. X is negative, y is negative. So, if x is negative, that makes cosine negative. Y is negative, makes sine negative. Now, if x and y are both negative, then it's going to make a positive, right? So, we've got negative, negative, positive here. In this last one, let's see, x is positive, y is negative, and r is positive always. So x was negative, y was positive, r is positive here. Should have done that before. All right, so y is the only negative. So if it includes y, it's going to be negative. So sine and tangent are going to be negative, and cosine is going to be positive. Sine and tangent are negative, cosine positive. All right, so if I look at this, the things that are positive in the first quadrant are all of them. So A for all of them. Right? All. Sine is the only positive one in second quadrant. Tangent is the only positive one in the third quadrant. And cosine is the only positive one in the fourth quadrant. And as my college professor at the Mount, I wish I could remember his name. He also teaches at another high school, and he said, the way we remember this is all students take calculus. ASTC, all students take calculus. So that's how you can keep track of which trig function of sine, cosine, and tangent are positive in which of the four quadrants. That's all I had there. Yep. All right, so now what happens when it's on an axis? An axis. Axis? Axis, I think. All right, so let's see. Well, I have tried doing this with an actual triangle, and when it's on an axis, that makes it really hard to draw a triangle. So if it's at the 90 and it's on a unit circle, let's draw a unit circle here. Oops, I'm not talking a square or circle, come on. There we go. Here's my center of my circle. And that's the radius. The radius of my circle is this distance here. That's the radius. So my radius, and let's say this is the point 0, 1. Left to right, 0, up 1. So that makes my radius of 1. And now I've got x, y, and r. And now I can do opposite and adjacent, hypotenuse all together. Remember, we said that sine is opposite, y over r. So that's 1 over 1, or 1. So sine of 90 is 1. Cosine of 90, that's x over r. 0. Tangent of 90 is y over x, or undefined. So there you have the 3 trig functions and how you would find them. I used to try to draw a triangle and make up a triangle like it was just a little to the side so I could draw this triangle and call the distance, like if I pretend it's a little over here, and I used to draw the triangle like this, and there's theta, and I said that the radius was 1, the height was 1, and the distance here was 0. But I didn't find that as satisfying as doing the unit circle style and x, y, and r. So that's why I don't do that anymore. Whoop, whoop. There we go. All right, so let's continue. Now we're talking about something called law of sines. Now the law of sines states that the sine of angle A over side A is in proportion to the sine of angle B over side B, which is in proportion to the sine of angle C over side C. So if we were to use this triangle and we were to set up some information here, let's say that, remember, angles are capital letters, so capital C, that's supposed to be a capital C. Capital C, capital A, and capital B. Those are our 3 angles, A, B, and C. And lowercase letters for the sides, let's see, not sure why I did that way. Let's make that red to match the others. And then let's do sides of, no. Now I can do this, all right, I can do this. Opposite A is side A, opposite B is side B, and opposite C is side C. And there are your labels. All right. If we're given a few pieces of information. The measure of angle C is 75 degrees. That's what we're starting with. Measure of angle B is 59 degrees. And side B is 24 units, whatever those units might happen to be. So we're asked to find the rest of the values in the triangle. So to do that, the easy first one is angle A. Measure angle A. Well, that's so easy. If I've got two angles of my triangle, I add them up, subtract from 180, and that gives me measure of angle A. So let's see. Angle A is going to be 75 plus 59. That subtracted from 180. And that's going to be, let's see, 75 plus 59, 134. Subtracted from 180, 46 degrees. And that's how you find the missing angle if you're given two angles of a triangle. Now, to continue to find side A and side C, which we don't have, I'm going to start with the angle and side across from it, by the same letter, that we currently have. We currently have angle B and side B. So sine of angle B, 59 degrees, over side B, 24, equals. Now you can take your pick as to which angle, or side, excuse me, you want to find first. Let's say, now obviously this triangle does not match the angles that we're working with, because this is an obtuse triangle. So don't assume anything from the diagram. On the MCAS test, they tell you consistently the diagram is not to scale. So don't assume anything by the diagram. Let's see, sine 75, and we're trying to find side C. So the first thing I'm going to do here is I'm actually going to do the calculation on my calculator for the sine of 59 degrees. And that is 0.8572. 0.8572. Remember, you're going to round your trig values to 4 decimal places. Sine of 75.9659. And there is my beginning. Double checking, yes. All right, so this takes a little bit of time. We're going to now cross multiply to find the values here. This comes out to 23.1816. Do not simplify this or round this until the very end. And the other is 0.8572C. I now need to solve for C by dividing both sides by 0.8572. That gives me C equals 27.04. I don't think that's the exact value, that's the rounded value. We're going to do 2 decimal places for our rounded values. Let me just double check here. 23.1816 divided by 0.8572. And sure enough, it does not come out exactly to that, so that's the rounded value. I could even put the approximate symbol here instead of equals. That way we know it's only an approximate answer. All right, so now, once I've found that, I can go back up, 27.04. Side C, 27.04. I can even fill it in on my diagram if I wanted to. I'm not going to because that would make it a little messy. It's a little tight, but I could. Well, now that I know side C, the only other side I'm missing is side A. So I'm going to continue to use side B and angle B. Let's see. Side B. Sine of 59 degrees over 24 equals sine. Now angle A is 46. Over side A we don't know. And we'll proceed to do the same type of work we did before. 0.8572 over 24 equals. Now 46 degrees, when we take our sine, is 0.7193. And that's over A. We then cross multiply. So what's that come out to? 17.2632. 2632. 0.8572A. I'm going to divide both sides by 0.8572. So A is going to end up to be approximately 20.14. A 20.14. Now I've solved for all the sides, all the angles, and that's the process you use for finding the sides and angles given a particular triangle. Let's take a look at this one. Why don't you give this a try, see how you make out, and then we'll work together on it. All right, now that you've unpaused, let's see what we can do. Now this one starts off where we have two sides, one angle, and this one we're only going to try to find x. We're not trying to find the whole triangle. This is not a right triangle. Please notice that. So, law of sines. I have sine of 70 over 20, the opposite side, sine of x over 21. I'm solving for x here. Well, I know what the sine of 70 is, 0.9397. And then I'm going to cross multiply. Now, this side, easy to do. Let's see. We're going to round the final answer to, oh, maybe I don't have to round. No, I'm not rounding. To 19.7337. Just going to double check that on my calculator. 0.9397 times 21. Yep, all right. And that's going to equal 20 times the sine of x. And that's how I would suggest that you do that, just to be sure that it's clear of what you're doing. I'm going to divide both sides by 20. Sine of x equals 19.7337 divided by 20. All right. 0.98665. When I take now, here's the next thing. There's a button on your calculator that says sine. Now typically, not always, but typically above that as a second function, you're going to see this. That's not sine to the -1 power. That's not the reciprocal of sine. That's the inverse of sine. And it's the opposite function. Like squaring and square rooting are opposite functions. Sine and inverse sine are opposite functions. So we're going to take the inverse sine of this value, and that tells me what the value of x is. And in this case, that would be 80.64. Now, looks like that's what the book is going to look for, 80.64. And that's going to be good enough for us as well. That's close enough. Degrees, excuse me. Degrees. And there's your final answer for this one. And that's it for today. Have a great day.